Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Under Lock and Key by Matt Tressel. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. And we have a ciphered sum dot, where digits in cells touching a sum dot sum to the value of the sum dot, which in this puzzle must be deduced by the solver. Dots with the same letter have the same value, and dots with different letters have different values. So basically, these four cells must add up to A. These four cells must add up to A. These two cells must add up to A. These two cells must add up to B. These two cells must add up to B, etc., etc. These two cells must add up to C. These two cells must add up to D. These four cells must add up to D. And these four cells must add up to C. And again, dots with the same letter have the same value, and dots with different letters have different values. So the two cells that add up to B cannot add up to the same as the two cells adding up to the C. So A, B, C, and D are different values. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. Two A's, which have a doubling, add up to at least 7 digits plus another single digit. So that means the first 7 digits in the same box or in the same row or column means that you have to have unique digits. So it's 7 unique digits add up to is 1 through 7 at minimum, which is 28. Plus another digit must add up to 2 times A. So 1 through 7 is 28, plus 1 is 29. Divided by 2 is 14 and a half, so everything above 14 and a half is possible for A. But we also know A cannot be 2 unique digits. So it cannot be 16 or 17, because if it were, these 2 unique digits would eliminate that unique digit for the A there. So this has to be then 6 through 9, because it's guaranteed to be 15. So this has to be 15 plus 15. So we have the 1 or the 2 doubled. The rest of all of the digits as a whole add up to either 28 or 29. And then we have the 1 or the 2 counted twice to add up to 15. That means we are guaranteed in box 1 a 9 in one of these spots, and I think it has to be 7, 8, or 9 specifically. Because to add up to 28 for the 7 digits is 1 through 7. To add up to 29 for 7 digits is 1 through 6 and 8. So A definitely adds up to 15. So whichever ones add up to 15 here, we know C is the sum of 2 digits, B is the sum of 2 digits, D has to be the sum of 2, and we know B is not adding up to 15. And in fact, we have A adds up to 15. We have 2 C's in the same box, so that cannot be unique digits. Well, actually, B and C can never have unique digits. Because if they did, to add up to, well, okay. So B is in 4 times in box 5. That means 4 times B is equal to some value greater than 36 or greater, or 45, it can't be 40, less than 45. So between 36 and 44. So B could be then 9, B could be, so 4 times B is equal, again, 4 times B is somewhere in between 36 or 44. So that means 4 times B is equal to 36, 40, or 44 because those are the only even digits. So this has to be 1, 5, or 9. So B must be then 9, 10, or 11. Okay. And B plus A equals the sum of 2C because these add up to C. So B plus A equals 2C. That means since A is odd, B must also be odd. So B cannot be adding up to 10. So B is either 9 or 11. If B is 9, that means C has to be 12. We know one of these is 9. That means the other one must be 7, 8, which would force this to be 6. Okay, so these have to be different sets, right? If they were the same set, the problem is that you would have 7, 8 here and 7, 8 here, which would eliminate 7 and 8 in both of these cells, so they would both have to be 9, which is not allowed because you'd have a repeat 9 in the box. If both of them were 6, 9, the problem is 9 wouldn't be available in this box anymore. So these have to be different sets. So we're going to make this red, and we'll make this yellow. So this has to be yellow, which means this has to be red. So we are guaranteed one of these sets is 6 and 9. Right? Because one of these is 7 or 8, the other one's 6 or 9. But we have both of them adding up with B to add up to C. So if we add it up to 12, which is what 9, if 9, B is 9, A is 15, 9 plus 15 is 24, divided by 2 is 12. The problem is one of these is 6, which would have to add up to 6, with 6 to add up to 12. So it cannot be 12 that it adds up to. So therefore, it must be 11 and 15, which add up to 26. So C must be 13. So B must be 11, which means this must be a 1 here, right? 44 divided by 4 is 11. And then 45 minus 44 is 1. So this has to be 11, which means this is 4 through 9. Because we know C adds up to, what, 13. Yeah, 13. That's the reason why we know this is 4 through 9. Because it has to be 4 and 9 adding up and 6 and 7 adding up. So, if this is 7, 8 as a pair, that means this is 5, 6 as a pair. If this is 6, 9 as a pair, it must be 4, 7 here as a pair. So this is 4, 5, 6, 7, 4, 5, 6, 7 there. So these add up to 11. We have this adds up to 13. So this is also 4, 9, 5, 8, 6, 7. Interesting. This is also 4, 9, 5, 8, 6, 7. Well, what can this not be? This cannot be 6 and 7, because that would eliminate all possibilities for this A cell. So we are guaranteed this is 4, 9, or 5, 8. This is 6, 9, or 7, 8, which eliminates 8 and 9 in the rest of the column. So this is 8 or not 8 or 9, 6 or 7. This has to be 8 or 9, which means in the rest of column 9, we have just 1 through 5 remaining. Okay. B again adds up to 11. So this could be 2, 9, 3, 8, 4, 7, or 5, 6. This cell sees all 4 of these digits. So it can, and these are different digits, red and yellow. So this cannot be 6 through 9. It's 2 through 5. This can't be 2 through 5, then it's 6 through 9. Same with this digit. It cannot be 6 through 9, so this is 1 through 5 there. So this yellow digit, where is it in column 9? Can't be here, can't be in the red, can't be here anymore because of the 8-9 pair here. Can't be here, so this is 4 or 5, which is 8 or 9 there. So this has to be the yellow 8-9 here, which means this cannot be 8 or 9 here because it sees both the red 8-9 and the yellow 8-9. So this is not 2 or 3, this is 4, 5. This 4, 5 pair eliminates 4 and 5 in the rest of the row. So this is 1, 2, 3 then. With 6, 7, 8, 9. We don't know which. Okay. That means yellow has to be one of these 3. So D, interesting, is the sum of 4 unique digits, so it's at least 10. It cannot be 11, 13, or 15, so it's 10, 14, 16, or 17. Okay. This is 6, 7 as a pair, which means we cannot have 6, either this is 6 or 9 or 7 or 8. This is 6 or 7. That eliminates 6 and 7 in the rest of the box. So this is 1 through 4, 5, 8, and 9. No 8 or 9 here because it sees, again, both reds and the yellow. Yellow cannot be either of these. So we have yellow as one of these sets. This cannot be 1 through 4. If this is 1 through 4, that would eliminate all possibilities for that cell and all possibilities for that cell. So therefore, D cannot be 10. It can't be 11, 13, or 15. So it's 12, 14, 16, or 17. We are guaranteed 1 digit from 1, 2, or 3 here. Can this actually ever be? So this is 6 or 7, which means this can't be 6 or 7 here, right? So one of these is 6 or 7, right? Because you have to have 9 in that remaining digits in box 8 cannot contain 6 or 7. No 6 or 7. No 1 here. Same with box 6. This cannot be 8 or 9 because it sees both yellows. This can't be 8 or 9. Actually, it could be. We don't know that one. We have a 6, 7 pair in row. This is either 4, 7, or 5, 6. This is 4, 7, or 5, 6, which means we have a guaranteed 6, 7 in row 8, which means this cannot be 6, 7, which is 8, 9. This can't be 8, 9. It's 6, 7. That means this can't be 8, 9 here because it sees both 8, 9s in the box. Remaining digits of row 8 cannot have 8, 9, or 6, 7. So this is 1 through 5 here. the question is, can this actually be 8 and 9 here? If this is 8 and 9, that means all of 1 through 5 would have to be here. This would add up to 13. If this is 8, 9, this can't be 6 or 7. Okay. And that can't, so this cannot be 8 or 9 here, because that would force this to be 1, 2, 3 as a pair. We'd have too many 1 through 5s in box 9. So this has to have the red 8 and 9, which means this cannot be 8, 9 here. It's 1, 2, 3, which means the red 6, 7 is here. Yeah, this is red 6, 7 here. This is yellow 6, 7 here. This is yellow 6, 7 here. So this must be a 6, 7 pair here. Right? To add, this is guaranteed to have a 6 or 7 here. Right? Because if this is 6, 9, this has to be 4 and 7. If this is 7, 8, this has to be 5, 6. So this cannot be yellow 6, 7. It must be red 6, 7, which makes this yellow 6, 7 here. That means this is 13. Well, 13 can either be 7, 9. 13 plus 3 is 16. 13 plus 4 is 17. So we're guaranteed this has to be 1, 2, or 1, 3, which eliminates 1 in the rest of the box. That means we're guaranteed 5 has to be one of these two. 4 has to be one of these two. Because it cannot be 4, 5 here. You can't have 4, 5 here. So this is a 4, 5 pair, which eliminates 4, 5 in the rest of the column. So this is the yellow 4, 5. Adding up to 11. That means this is... Does that work? Okay, so if we have 7 here and 8 here, this adds up to 11, so that would be 4 and this would be 5. If we have 6 here and 9 here, this would be 4 and then 5. So yeah, that works. So D has to be either 8, 9 or 7, 9. To add up to 16 or 17. So 1's definitely here, which means this cannot be 1. This sees both the red 4, 7 and the yellow 4, 7 here. So this cannot be, 4, 7 through 5, 6. So it cannot be 4, 5. So this must be the equivalent yellow 4, 5. And the equivalent red 4, 5 here. So the red 4, 5 must be here. We are guaranteed a 9 here, which means this cannot be 9. So this has to be 7 and 8. That forces this to be 9 here. This cannot be 9. This is 8 and 7. So there's no 8 here. This is definitely 9, which means this can't be 9 here. No 9 or 8 here. So all the reds are 4. This cannot be 7, 8. It's 6, 9, which forces this to be 4, 7, which means this can't be 7. It's 6 and 5. This is then 6 and 5. That's 7. This is 4 and 9, which makes this 9 and 6. No 6 or 9 here. It's 7 or 8. No 4 or 7 here. It's 5 or 6, which eliminates 5 in the rest of the box. No 8 in the rest of the box. No 1 here. This cannot be 7, 8, or 9, so this can't be 4, 5, or 6 because this adds up to 13. This cannot have 4 in the remaining digits. 5 can no longer be here. This can't be 5. Where is 5 in box 8? It must be here. So that's 5. Okay, what do these add up to? Remaining digits in box 1, well, column 3, are not 7, 8, and 9, so we have 1 through 6 here. No 1 here. Remaining digits in column 1 are 1 through 6. And this can't be 6 here because of 6 in the row. This cannot be 9 here because of 9 in the box, so this is guaranteed to be 8. No 9 here because of 9 in the row. B, again, must add up to 11, so no 1 here. So either this is 2, 9, 8, 7, adding up with 3, 4. This cannot be 9 here. This cannot be 2 because of 9 in the row. We are guaranteed one of 7 or 8 is here in column 2. We don't know where. Okay. We have a 7, 8, 7, 8 pair in row 6, which eliminates 7 and 8 in the rest of the row. We can remove the coloring, I guess, now. Which means this cannot contain 7 and 8. So no 3, 8, no 4, 7 there. So this is either 2, 9 or 5, 6 here. And it cannot be 5, 6 because of the 5, 6. That would eliminate all digits here. So this must be 2 and 9 in row 6, which eliminates 2 and 9 in the rest of the row. Remaining digits in row 6 then are 1, 3, 4, 5, and 6. No 1 here, no 5 here, so this could be either, this can't be 5 and 6, so this can't be 6, it's 3, 4 with 7 or 8, which means we have a 7, 8, 7, 8 pair in column 5, which eliminates 7, 8 in the rest of the column. This cannot be 7 or 8, it's 9 and 4, adding up to 13 here then, which eliminates 4 and 9 in the rest of the row. So no 4, no 4 here. Remaining digits are 2, 3, 5, and 6, and this cannot be 2 to add up to, because we have a 2, 9 pair in the box. Where is 9 in column 4? Can't be here because of the 6, 9 pair in the box. Can't be here because of the 2, 9 pair in the box. Can't be here or here because of 9s in the rows, so 9 has to be there. This has to be 8 with 5 or 6 here to add up to 11. Where's the other 7 or 8 in box 4? It must be here. Okay. We don't know whether D is 16 or whether it's 17. We know 4 cannot be here. Where's 4 in box 7? It must be here. It also eliminates 4 in the rest of the box. Okay. Remaining digits in box 5. Again, 3, 8, 4, 7, 5, 6. No 5 here, so no 6 there. Hmm. 5 and 6 eliminates 5 and 6 in the rest of column 2. So remaining digits in column 2 are 1, 2, 3, 7, 8. 4 can no longer be here. So 4 is definitely part of this A. We don't know which. We have in column 7, this is 1, 2, or 3. These are 1 through 4. And one of these is 2, 3, or 4 here to add up to 11. Well, that's 4 cells in column 7 requiring the digits 1 through 4, which eliminates 1 through 4 in the rest of the column. This can't be 1 through 4, it's 8, which means this can't be 8 here. That also eliminates 3 and 8 here. The rest of column 7 cannot have 1 through 4, 6, or 8. And we don't have a 9 anywhere. So where is 9 in column 7? It can't be here because of 9 in the box, and these are not allowed because of the 9s in the rows here. So this must be 9 here, and this is 2, which makes this not 2, that's 3. This can't be 2 or 3, it's 1. This can't be 1 or 3, it's 4. That leaves us as a 5, 7 pair. This 2 eliminates 2 in the rest of the box and the row. So this is a 1, 3 pair, which eliminates 1 and 3 in the rest of the box. So this is 2. That leaves that as 1. No 1 here. 4 eliminates 4 here. So that's 3 and 8 adding up to 11. This cannot be 3 and 8 here then. It's 5, 6 as a pair, which eliminates 5 and 6 in the rest of the box. This can't be 3 or 8. It's 4 or 7, which eliminates 4 and 7 in the rest of the row. So this can't be 7. This is 8, which means this can't be 8 here. This is guaranteed to have a 7. This 8 eliminates 8 here, so that's 7. That's 16, so it must be 6, 7, 1, 2, adding up to 16. This is 3. 2 eliminates 2 here, so that's 3. No 3s here. No 3 there. No 3 here. This 7 eliminates 7 here, so this is 8. Therefore, these digits add up to 28. So the 2 must be doubled for A to add up to 15. So this is 2, which means this cannot be 2 here. No 2 in the rest of the box. This is definitely 2 and 4 here. So that's 6. Therefore, the remaining digits here must add up to what? Must add up to 15 minus 6 is 9. Well, 1 and 8 would add up to 9. So it cannot be 8. You cannot have 1 here. And you can't have 5 here because 4 and 5 add up to 8 or 9. But 4 is already guaranteed here. So this must be then 4, 6, and 3. Which means 3 is eliminated in the rest of the box. So is 6. This is 1, 5 as a pair. Therefore, that forces this to be 7. So again, 2, 7 is 9, plus 1, 5 is 6, is 15. So that means 3 eliminates 3 here, it's 1. 1, 5 here eliminates 1, 5 in the rest of the column. This 3, that means this can't be 1, 5, this can't be 1, it's 2, which eliminates 2 in the rest of the column. This 3 eliminates 3 here, so it's 6 and 3. There's no more 1 or 6 here. This is 2 or 5, which eliminates 2 there, so that's 1, this is 2. No 2, 3, or 8 here, so this is 1. No 1, 2 here, it's 3 and 8. 5, 6 as a pair eliminates 5 and 6 in the rest of the column, so this can't be 6, this is 9, that's 6. 9 and 4 add up to 13. 7 and 6 add up to 13. 7 eliminates 7 here, so it's 4 and 7. 2 eliminates 2 here, so it's 5 and 2. 5 eliminates 5 here, so it's 6 and 5, which eliminates 5 here, so that's 6 and 5. 9 eliminates 9 here, so it's 2 and 9. 8 eliminates 8 here, so it's 7 and 8. 3 eliminates 3 here, so it's 1 and 3. We don't know where the 1s are. We have 8 2s. We know where the last 2 is. It has to be there. We have 8 3s. We know where the last 3 is. It has to be there, which makes this, actually, that's 7. But 3 was eliminated from here, here, and here. Where's the 3 in box 2? It has to be there, which makes this 8, which makes that 3. Where's this 7 eliminates 7 here, so it's 5 and 7. 5 eliminates 5 here, so it's 1 and 5. That leaves this as a 4. We should have 8 1s now, which we do. We know where the last one has to be. It has to be there. We don't know where the 4s are. We don't have enough information. We have 5 8s, or 8 5s, so we know where the last 5 has to be. It has to be there. 6s. In column 4, it must be here, which makes this 4 and makes that 6. So that's all the 6s. 7, we have 8 7s, so that's 7 there. We should have 8 8s. We don't, but we know this is 8, and therefore that forces that to be 8. And that leaves that as 4. Yeah, fairly straightforward, but I've done a whole bunch of Killer Cage Sudokus, so I'm really used to adding all these up. For me, it's probably easy level. But for probably most people, it would be probably challenging level. So I think I would probably just put it there. Put it at challenging. I don't know. Felt very straightforward to me. But again, I'm used to these sums and I'm used to doing all of these. So maybe that's why it was rather simple for me. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.